Homework 406, Part 2, starting with quadratic word problems. The width of a rectangle is 1 unit less than the length. The area of the rectangle is 72 units. So it's important that you understand that area is the amount of space inside the two-dimensional figure, and that your two dimensions have to use the same letter. So if L represents length and W represents width, one of those letters needs to be erased and replaced with some other information. It looks like we have that information here, that the width is 1 unit less than the length. So I'm going to erase the letter W and replace it with 1 unit less than the length. For a rectangle, the formula for the area is length times width. So for us, 72 is equal to L times L minus 1. So I'm going to need to distribute this L. And then I'm going to need to move this 72 to the other side, giving me 0 is equal to L squared minus L minus 72. Okay, so now I have my actual quadratic equation. L squared minus 1L minus 72. So L squared minus 1L minus 72. So we could try to solve this by factoring. We could try to solve it by completing the square. We could try to solve it by using the quadratic equation, or the quadratic formula. Sorry, this is a quadratic equation. The quadratic formula is this right here. Now, this quadratic formula will work for anything, but if you're feeling like, you think you might be able to factor this by looking for something that multiplies to negative 72, but adds to negative 1, it would have to be some numbers that are very close to each other, that they're only 1 unit apart. That's what that means. So you could pick up a calculator and you can, try and start guessing. You can do 72 divided by 14, nope, that's a decimal. 72 divided by 9, oh, that's 8. So I'm thinking we might get a negative 9 and a positive 8. Again, I could use this, or I can try and use this. So since negative 9 and 8 is a pretty nice factor, I'm going to set those up. L plus 8, L minus 9, and I'm going to get my two answers, right? It's either this one that's a 0 or that one that's a 0. And when I see my two answers, I have to think about which one of these would make sense. Even though both of these numbers make the equation true, could I have a width or a length of negative 8 units? No. So this one would have to be dismissed. It would have to recognize as impossible for this question, and that leaves me with 9 units for my length. So if the length is 9 units, then what is the width? Well, the width is 1 unit less than the length. What is the width? That's the question. So the length is 9, and the width is 8. Let's try that one more time. The difference of the square of a number, so this is the square of a number, and this is a difference. The difference of the square of a number and 10 is equal to 3 times that number. Find only the positive solution. So because I have an x squared and I have an x, I'm going to need to write this in standard form. So I'm going to bring this over, giving me x squared minus 3x minus 10 equals 0. Now I can try and factor this by looking for something that multiplies to negative 10 and adds to negative 3. I think I can figure that out. I think 5 and 2 would work here. And because my bottom number here is a negative, that means the larger number gets the negative. So x minus 5 times x plus 2 are my factors. That gives me solutions of positive 5 and negative 2, but they only want the positive answer, so the answer is 5. One more time. Looks like we're back to our rectangles here. The length of a rectangle is the sum of the width and 1. So we don't know the width, but the length is the width plus 1. The area is 72. Again, we have that same 72. So it looks like we have an area of W times W plus 1 equals 72. Oops, that's a weird look at 7. It looks like a 22. 72. So W squared plus W equals 72. Move the 72 over. W squared plus W minus 72 equals 0. Pretty much have done this already. The two numbers that, oops, I'm giving it away down here. The two numbers that multiply to 72, negative 72, but add to 1 are 9 and negative 8. 9 and negative 8 this time. So W minus 8, W plus 9 equals 0. That means my solutions are 8 and negative 9, but you can't have a negative dimension. So 8 is the width. Right? 8 is the W. But they're not asking me for that, they're asking me for the length. So the length is 1 more than that, so the length would be 9. So I'm going to type that in here. The length would be 9. Alright, let's try the next lesson. Select the form to find quadratic features. Okay, a quadratic function is hidden from view. You must find all intervals where the function is decreasing, right? So let me give you a little sketch here. If I have a pair of axes and my function is in red, if it was upside down, then from the vertex down would be decreasing. If my function was upward facing, then from negative infinity to the vertex would be decreasing. So if I knew where the vertex was, I would know where it is decreasing. So that's going to be what I select, the vertex form. Remember, the vertex form is the opposite of this number, the same as that number. So negative 3, negative 32. And this number out here tells me whether it's concave up or concave down. That's positive, so it is concave up. And the vertex is down here, negative 3, negative 32. Right? Negative 3, negative 32. So everything in this space up until here is decreasing. So from negative infinity all the way to negative 3. From negative infinity to negative 3 to the vertex. All of that is decreasing. So I'm going to type that in using interval notation. From negative infinity, use this button here, then arrow over to negative 3. Once I hit negative 3, I change directions. Alright, let's try that again. Quadratic function is hidden from view. You must find all the intervals that are increasing. Oh, that's the same thing. If you have a parabola, then it's increasing from the vertex to the right. If you have a downward facing parabola, then it's increasing from the left to the vertex. So I definitely need to know where the vertex is. So that's what I'm going to choose from my list. My parabola is pointing up with a vertex at negative 4, negative 8. Oops, I don't know why I did that. Negative 4, negative 8. Right, so at negative 4, negative 8, there's my vertex. It's an upwards facing parabola, so it's increasing over here. So from negative 4 on. So as long as x is greater than negative 4, we're good. So we can use interval notation like this, negative 4 to infinity, or we can just say x is greater than negative 4. We can do either one of those. Alright, this time I want to find the X intercepts, right? Those are the solutions, the roots, the zeros. So if I want to know the X intercepts, I want to know these values right here. Those are the solutions, the roots, or the zeros. So the best form for knowing that right away is factored form. So I want to see factored form because I know that the roots are always the opposite of my factors. So the roots are -5 and +3. The roots are -5 and +3. Write your answers in the form of x and y. Okay, so if you are a root, you have an x value, but your y value is always 0. You have an x value, but your y value is always 0. So we had roots at -5, -5, 0, and 3, 0. Excellent. There they are. All right, one more problem. We did X intercepts already. Maybe I can skip to one that isn't like this. Okay. Quadratic function is hidden. You must find the maximum value. Well, a maximum is also known as a vertex. So if I know the vertex, I'll know the maximum value. Remember, the vertex is the opposite of this number and the same as that number. And the max is the y value. The max is the y value. They want us to choose the form of, how do they want us to write our answer? It doesn't say. I'm going to say the answer is y equals 2. Let's see if they like that format. Oh, whoops, what did it say? Please do not write an equal sign. Okay, just type the number. Okay, the number is 2. Excellent. We already just did this one. Let me see if I can jump ahead to another question. Same thing, jump ahead to another question. X intercepts, I did. How about, oh, this one. Quadratic function is hidden from view. You must find the y-intercept and write it as a point. Well, if you have a y-intercept, which for us is right there, if you have a y-intercept, then that means your x value is 0. And your y value is that particular number. So when it says it wants us to write our answer as a point, we're definitely going to have a 0 in there. But now we have to figure out where that y-intercept is. And the best format for seeing a y-intercept is standard form. Standard form. Standard form has an a, b, and a c value. And the c value is the shift up or down. So that's the y-intercept. So my y-intercept is -32. And there's always a 0 in the x position. So 0, -32. That's what we're going to type here. There's one y-intercept, and it is at 0, -32. Excellent. That concludes our video for homework 406.